Good morning. My name is Nguyen Thuy An. Today I will present on the topic Multilayer graphene oxide silver nanoparticle for stable, highly sensitive, and reusable soft platform. The Raman scheduling is the inelastic scheduling of electromagnetic waves, in which the inelastic scheduling is equal to the vibrational energy of the material molecule. Therefore, it is considered a biological fingerprint of the molecule. However, it had a major disadvantage. The probability of Raman scattering occurring is extremely low, so it is very difficult to receive signals at low concentration. Surface-enhanced Raman scattering source was born to overcome this drawback. Such is an effect in which Raman specializes in 300 to millions of times when they lie on raw metal surfaces, so it has received increasing research attention in recent decades. Is considered one of the powerful qualitative and quantitative analysis tools with ultra-sensitive detection capability and high selectivity to identify molecular for analysis without overly complicated sample preparation. Therefore, it is increasingly widely used, such as detecting toxic in food, chemical analysis, and biomedical diagnosis, and detecting dyes causing environmental pollution, and determining pesticide residue extract concentrations. There are two accepted and widely known short enhancement mechanisms: electromagnetic mechanism and chemical mechanism. Silver is considered the most important plasmonic material. Silver nanoparticles can be absorbing and catalyzed with a prodigious efficiency. Moreover, the notable properties of silver nanoparticles are non-toxic, stable structure, antibacterial, chemical stability, catalysis, and easy modification of surfaces to bend to biomolecular and rock molecules via substances concerning the amino theory. Moreover, silver is now to the PET electromagnetic field enhancing metal among plasmonic metals, so it is often used as the base for such application. Graphene and its oxygenases also become the promising material for sensing because of their interesting electronic, uh, optical, and chemical properties and good chemical stability. Not as the fluorescent quiescent agent, graphene had become an ideal active substrate for the fluorescent molecule. Besides, reduced graphene oxide (RgO) is also used as the potential substrate for such application, inspired by such enhancement of noble metal material, noble nanoparticles, and and combination of RgO and silver nanoparticles hint a new platform to improve the such effect for the very famous Raman reporters. Modeling rule is often widely applied in the dyeing industry and household products such as dye fabrics, cotton fiber, paper, or products from bamboo, and the treatment of some diseases. However, it is usually discharged into water bodies with proper treatment to polluting the environment. It is known to cause eye, skin, and even cancer with long-term exposure. Consequently, the determination of methylene blue is an urgent need to detect as low as possible the concentration of it in water. In this study, we presented an investigation of such activity on audio silver nanoparticle using the methylene blue at the dye molecular. Next is part 2, experimental. Silver nanoparticles were synthesized by chemical reduction method, and the synthesis procedure is shown above. It is the process by which we repair a substrate with a two-layer silver structure for analysis using a 42 nanometer wavelength excitation laser sound, and the signal is received by the detection. The results of RGO6 was confirmed by performing a Raman measurement. The ID per IG ratio was calculated to be 1.13, which confirmed the better quality of the repair RGO. In addition, the FTIR spectrum also showed characteristic bits of RGO, indicating the reliability of the material. The HR10 results indicated that the thin film of RGO6 possesses a relatively uniform thickness and is transparent with wrinkles, smooth surfaces, and slightly false were observed. The maximum absorption peak of RGO at the 260 nanometer was observed due to redshift from the characteristic peak of the GO at 240 nanometer. The characteristic LSPR absorbance bank of the silver nanoparticle was also found at the peak around 429 nanometer, which was consistent with previously reported literature for citrate functionalized silver. Then the audio film deposited on the glass was investigated over the period of immersion of 2, 4, and 6 hours through Raman spectroscopy and physical imaging, showing that the approximate time is 6 hours for the audio coating surface to have a stable morphology, large surface area. Next, the properties of silver nanoparticle multilayer substrate are studied. The HRD pattern of the film shows all the characteristic diffraction peaks of both RGO and silver nanoparticles. The intensity of diffraction peaks gradually increases with deposition time. The critical size calculated according to the departure formula is 26.4 nanometer. The morphology of the multilayer film shows the silver particle have an almost spherical shape. The diameter of the silver nanoparticle is measured to be about 18 nanometers to fit same image. The deposition time of silver nanoparticle is 2 hours, so that the silver particles are evenly distributed on the surface of the audio layer. The audio silver nanoparticle substrate had the ability to accept methylene blue stain, reaching a detection limit up to 10 to the power of -9 m, with a correlation coefficient R squared of 0.9848, showing high reliability of the results. The Raman enhancement factor was calculated up to 10 to the power of 8. The uniformity of the membrane was evaluated by recording the Raman signal of muslin blue at the concentration of 10 to the power of minus 5 m at 7 random positions, so that show the deviation, the relatively low standard of 4.91% indicates high signal uniformity. In addition, we studied the possibility of enhancing Raman scheduling with a different substrate structure, such as silver thin film, silver nanoparticle, silver thin film and silver nanoparticle, silver film and gold nanoparticle. The result showed the silver nanoparticle and audio multilayer structure get a lower detection limit and increase factor very high. In conclusion, we have successfully synthesized silver nanoparticles and audio and application to detect muslin blue, demonstrate the exercise sensitivity of the substrate with a limit of detection reaching 10 to the power of minus 9 m. The enhancement factor is 10 to the power of 8, and excellent reproducibility and homogeneity 4.91%. Thank you for your attention.